To the another important topic, and it is the concept of coherent sources. Now this concept is very important in connection with sustained interference. Now when we say sustained interference, we mean the interference pattern which is not changing with time. That is, the interference pattern remains constant. Now the coherent sources are those sources which are derived from same one source, that is atomic oscillator. We know that fundamentally we get light due to atomic excitation and de-excitation. So our source of light is basically atomic oscillator, and the light emitted by them have same frequency. Amplitude of wave may or may not be same. The phase relationship doesn't change with time. The initial phase difference at the time of emission between the waves from coherent sources is either zero or a constant. Thus, coherent sources give out waves which have point-to-point phase correspondence or a relationship. In nutshell, coherent sources are the sources which emit light waves of same frequency. Amplitude may not be same, having constant phase relationship. That is, phase relationship between the waves is not a function of time. Now these coherent sources are produced by two methods. The first method being by division of wavefront. Now what we do in this method, the wavefront is divided into two or more parts by the use of mirrors, lenses and prism. There are many well-known methods which exploit this method of production of coherent sources. The examples are Young's double slit experiment, Fresnel biprism, Lloyd single mirror, etc. As a part of JEE syllabus, we will be studying Young's double slit experiment in detail. The second method is by division of amplitude. In this method, the amplitude of incoming beam is divided into two or more parts by partial reflection or refraction. These divided parts travel different paths and finally brought together to produce interference. This type of interference needs broad source of light. The common examples of such interference of light are the brilliant colors seen when a thin film of transparent material like soap bubble or thin film of kerosene oil spread on surface of water is exposed to a broad source of light. In fact, thin film interference is an important topic from IIT JEE point of view, although this is not very clearly written as part of syllabus, but in past there have been many problems based on thin film interference. In this chapter of interference, we will be studying basically two categories of interference. One is by division of wavefront, which I have already mentioned, and that will be Young's double slit experiment. And under the category by division of amplitude, we will be studying thin film interference. Now let's see some of the common method to produce a pair of coherent sources. The double slit method. Now in the double slit method, light from source S is limited to a narrow beam with the help of a slit S. The emergent light is made to fall upon a screen containing two slits S1 and S2 placed symmetrically with respect to the slit. In that case, both S1 and S2 are illuminated by the same wavefront. Therefore, the beams of light coming out from S1 and S2 will have no phase difference. Thus, S1 and S2 can be treated as coherent sources. Young made use of them in his famous Young's double slit experiment. Let's take up the second method of production of pair of coherent sources. Now in this method we use source and its own virtual image. The light from source S is made to fall on a plane mirror M as shown on the screen. Point of observation P on the screen, AB receives a direct light